Okay, we're going to start today with a learning check. We're going to label acid, base, conjugate acid, and conjugate base for each of the following reactions. These are Bronsted-Lowry. So take some time, write it down, and label acid, base, and conjugate acid, conjugate base. Go ahead and pause the video. All right, you should have been able to do that. We're coming back. If not, quickly pause this again. We're going to correct it. It's 1 point for each one. So acid, base, conjugate base, base, acid, conjugate base, and conjugate acid. So 4 points for number 1 and 4 points for number 2. We're going to go on to the second part of the quiz. Here we go. Given a pH of 8.3, what is the concentration of hydronium and hydroxide ion, and what is the pOH, and is the solution acid, base, or neutral? Go ahead and pause the video. Alright, now that you've unpaused the video, we are going to correct this part of the quiz. The first thing is that it's 8.3 solution, so it is a base because it's above 7. We subtract 8.3 from 14 and we get the pOH as a 5.7. That means the concentration of hydrogen is 10 to the minus 8.3, which is 5.01 times 10 to the minus 9, and the concentration of hydroxide is 10 to the minus 5.7, or 2.0 times 10 to the minus 6. We have a total of 6 more points that we could have got on this point, on this part of the quiz, for a total of 14. So score it out of 14, and that's what's in your quiz notebook. All right, now we're going back to notes. So we're going to talk about acid-base indicators and pH meters. We can have indicators that we put into solutions to tell us by the color what pH it is. It's just basically an equilibrium reaction, and depending on how much hydrogen I have, depends on what color I get. These are usually weak acids or bases for indicators. We usually use a universal indicator, which will give us a broad range, a rainbow, that we can quickly find what the pH is. pH paper that we've used is coated with a wide range of colors, or will exhibit a wide range of colors just like the universal. And we've used that already in our home lab. pH meters use the voltage between two electrodes that are placed in a solution to determine the pH. And we won't be using these in regular, but honors and AP do use them. We are going to be doing a titration as part of the investigation that we've been doing, because one of the water samples we ran out of pH paper, so we're going to do a titration. Basically on the titration you put the known solution in the burette, the unknown in the bottom but a specific amount, and an indicator in the bottom. And you add the known until the indicator changes color. So for the acid-base reaction, we need a balanced equation. From the balanced equation we need to have an acid and a base, and this acid is oxalic acid, and we've actually seen that before. That's the one that looked like that, remember, on our solutions video. So here we go, titration. First we're going to set up the known in the burette. So we're going to fill it up above the 0, and then using the burette stopcock we're going to open it and bring that level down so the bottom of the meniscus is right at 0. Then we're going to add an exact amount to our flask of our unknown and add to that an indicator so that we will be able to see when the end of reaction is. Then we're going to be stirring the flask with our unknown in it as we add the known to it, drop by drop, until the color changes. Then we stop. That is called neutralization. So, review. We have a burette. We're going to put the base of the known concentration here. This is a stopcock. We're going to open it and add drop by drop to the unknown acid concentration. If we were to graph this as we did it, and we started with a base down on the bottom, down in the flask, we added acid, this is what the reaction curve would look like. The point at where they're equal, pH of 7, is the equivalence point. If we have an acid that has 2 hydrogens that has to come off, we end up getting this going on. So we have first point that we have the first hydrogen coming off, and then the second hydrogen. So let's take a look at an example here. we have got 21.2 milliliters of aqueous acetic acid, HC2H3O2. The solution requires 15.5 milliliters of 0.215 molar KOH solution in a titration experiment. We need to calculate the molarity of the acetic acid, or our unknown. To solve for this, we take the molarity of the KOH and multiply the volume in liters to find the number of moles of KOH used. So we knew this concentration, we used this much, so we ended up using that many moles. We then write a balanced equation for what we've got that we're putting together. Once we've got the balanced equation, we can then say, okay, I can convert moles of this to moles of my acid. Once I've got moles of my acid, I can divide it by how many milliliters that I had in the volume of my sample, and I end up with the molarity. Okay, we're going to have you try and do some of these calculations and try a titration so we can finish up our investigation. Enjoy!